just get started with the presentation.
Everyone can see, right?
Yeah.
Yes.
Okay, so this presentation is basically, we're going to cover the fundamentals of FTC. In the last session, we covered installation to make sure that everyone has it set up and they're ready to progress and able to develop code. So the goal of today is basically, we're going to try to understand the basic development of like FTC code, the structure, so that you guys can go ahead and do it by yourselves. So what is an op mode? An op mode is a software module. So it's basically each one of your programs is going to be called an op mode. So whether that be autonomous or teleop, which is just one is like human controlled and the robot does it by itself. So it's just, we're going to write all of our code in what's called a class, but in FTC terms, we're going to call it an op mode. Just, we'll have one file that stores like all the code for that specific program. So as far as registering an op mode, we have these things called annotations. If you see the @ symbol, like in the corner where I'm pointing, we just add this to what is called a Java class to make sure that when the program's reading it, it knows that this is a teleop program, this is a autonomous program. So all the examples, if you noticed in the Android Studio file that we downloaded last time, it'll have the @ disabled in it so that all of these examples don't show up when you first download your code. So this is just there so that it doesn't automatically do it. When you comment out code as done here with the // it basically tells the Java compiler that we're not going to read this line and we're going to read it just like it's a comment, so you would read it as a human and not as like the computer would. So it would just skip over that line. And now Sanjit's going to take over to explain the different types of op modes.
Okay, thank you. So I'm going to be talking about the anatomy of an op mode, and like basically it's just saying like how they're built and how they're put together. So there's two types of op modes, and there's an iterative op mode and there's a linear op mode. And iterative op modes are sometimes just called.
Hey Sanjit, just to make sure, is everybody able to see the screen? Because I'm not able to see the screen.
Oh,
I can see it.
I can see it.
I see it.
Okay. Maybe I have multiple screens open. Okay.
Okay, so
okay, then.
You got it now?
Thank you.
Okay,
yeah.
Thank you. So this iterative op mode is sometimes called an op mode, just a regular op mode, or just called op mode. And the linear op mode is always called linear op mode. So now it's not required, but in general, an iterative op mode is mostly used for teleop, and in general, a linear op mode is only used for autonomous, but they can be used interchangeably with different types of structures. Like you can put a loop inside of the linear op mode and make it a teleop kind of program, and you can use it's similar to how the FRC thing works with the loops. Then for in a regular op mode for linear autonomous, but you basically never see anyone using autonomous, or not basically never, but it's more common to use teleop in a linear op mode than it is to use autonomous in a regular op mode. So we'll talk about the regular op mode first, the iterative op mode. The way it starts is there's 4 methods basically. So there's init, start, loop, and stop, and they basically do what you think they're what they're saying. Init is called as soon as you press the init button. And then what it'll do is it'll wait until you press the start button. And then once you press the start button, it does something once. And then it does this thing once, and then it starts calling the loop function. So everything you have in the loop function will be constantly repeating while you have the program running. Everything in the start function will be called once, and the init function will be called once. And stop is called at one time when it's pressed. So just to go over this again, there's the initialize button on the robot controller phone. and when you press the init button, what's inside the init function is called once. Then what happens is it waits until you press the start button. And once you press the start button, this is called once. And as soon as the start function is done being called, then it'll start looping through the loop function. So this loop function can be called basically an infinite amount of times because it will just keep going until you press the stop button. And as soon as you press the stop button, this will stop, and whatever's in the stop function will be called once. And just to be just as an just as a note, not all of these methods are required for every op mode. Like, you don't need a stop function. You might want a stop function if you want to like reset something. You might want, you don't always need an initialize function. You might want to just start. I mean, you always need an initialize function, but you might not always want a start function, right? You just want to just get right into the loop. So there's a couple things that aren't required, but in general, init and loop are required, but the only one that's truly required is loop. So yeah, this is just this every single one. So just kind of going through it again. Init is for initialization task, and it's run only once. Why do you need init? So the reason you would want init is because, let's say you have to reset the encoders on your motor, or like you want to make sure that the robot is in a certain position before it starts running the teleop. That's why you would use init. So this is kind of like init, you can think of as a setup function. So when you call this function, it's getting the robot ready for the actual teleop mode, but it's not actually running the teleop. Does that make sense? Okay, so then the start function, is the next one. Again, it's only executed once, and it's triggered as soon as you press the start button on the screen. And this is again like the initialize function is called as soon as you initialize it. So this is for setup, but if you need to do any more setup, that needs to be immediately before you start looping. This is what this would be used for. So this is kind of what it is. So you would use public void start, and you have to do @override, but we'll go over all of that. Next is the loop function. So this is the most important function. This is what's happening. This loops approximately every 10 to 20 milliseconds. So it's happening really fast. So it's like it runs through it and it runs through it again, it runs through it again. And what happens is this, as soon as it presses the start button, then as soon as the start function is over, it starts executing this over and over and over again. And what happens is, this is where you'll put the bulk of your code. So this is where you'll look for like, is the button pressed on the gamepad? Is the motor moving? Something like that. This is where you would be checking all those things, because this is basically just like a constantly checking things. This is what you would do in the loop. Then finally, the stop function is just what you do as soon as you're done at the end of the program. So similar to init, if you had to set anything up, like you had to reset the encoders, stop is for like if you need to set anything up before you're done. Like if you need to finish something, like if the arm is fully extended, you need to make sure at the end you need to retract it all the way. The stop function will make sure that, like, you can call it to make it retract in the stop function, something like that. So it does nothing by default, but you can override it. So it's similar to the start method. And then finally, we're going to look at the sample code in Android Studio. So we'll look at that in a second. And this is we're going to look at the K9 teleop mode. And it's a teleop because we're using the iterative op mode. And it's going to be a pretty straightforward one. So first of all, this is this. So if you want to see this for yourself, in Android Studio, there's a folder called there should be two modules that you see. You should see first or FTC robot controller, and you should see team code. If you don't see them, don't worry about it right now. You can talk to your person in the breakout room. So if you do see them, open the FTC robot controller folder. Then you should see like a I don't know the exact structure right here, but eventually you should find an external samples folder, or like there should be a folder called external.samples. If you open that, then find pushbot teleop tank _ iterative.java and open that. If you can't find it, that's fine as well, because we're just going to be looking at it on the PowerPoint anyway. So if you look at this first function, this init function, notice this annotation right here. Like Roshan said, everything starting with this @ means that it's an annotation. and these are put over these are put over like functions, variables, classes, anything that's declared like that. You can put annotations over it. So this override means that this class pushbot teleop tank iterative is extending a class called op mode, and since it's extending that class, it automatically has all the functions from op mode within it. But the thing is, the init function, right? We want to be able to do our own thing, so we're saying we're gonna override the function. We're gonna override the init function from op mode to do what we want to do, and that's basically what this means. And this robot.init hardware map is setting up everything. It's making sure that we know we know what motor is at which port and whatnot. And this telemetry.add data says hello driver on the driver station. So now the next part is, oh, also by the way, if you wanted to see where it is, you can see this FTC robot controller inside the Java folder. There's org.firstinspires.ftc.robot controller. There's external.samples. Now, if you look at hardware pushbot,
Sanjit, can you ask everyone to see if they can find it on the install, whoever has the, give them a few.
Everyone try to find this at least.
I would give them like 2 minutes to get Android Studio up and running.
Okay, yeah. Everyone get Android Studio up and running. I'll wait for 2 minutes.
My Android Studio is telling me to uninstall.
Can you and then for now it's okay, just watch the presentation. When you go into the breakout room, Vasu will help you because you're 6134. So Vasu will help you get that worked out. Just wait until you can go into the breakout room. Yeah. While we're doing this, does anybody have any questions about what I've been explaining so far?
How did you get to FTC robot controller?
Okay, so are you in Android Studio?
Yes.
Okay, so if you see, do you see the tab? Wait. Okay, so if you see the tab bar on the left of it, of the screen, this thing that says, or not tab bar, this sidebar, and you can see where it says Android right here. Make sure that this drop down is set to Android, not project or something else. So click on this drop down and make sure it's set to Android. Then you should see 2 folders that say FTC robot controller and team code. Oh wait, you were the one with the who was sharing your screen earlier, right?
Yeah.
Okay, so you're not going to be able to see it because the SDK isn't set up. But for now, just watch the
Okay.
presentation, and it will help you in the breakout room.
If you could you like raise your hand once you have got Android Studio up and running so that we know?
If you can't find it, that's fine. Just like wait. But try to find it. Like make sure your screen looks like this with the Android drop down, and so make sure you're having everything looking this way. If not, you can just look at the PowerPoint. Roshan, does that sound good, or is there anything else?
Yeah, so you can just follow along with the PowerPoint. I'll open up my Android Studio after Sanjit's done presenting. So then if you can't like figure it out then, hopefully you'll figure it out on the second run.
So I don't see many there are many still hands not risen. Are you guys having issues or? So if you guys are new and you don't know how to raise hands, it's right. Like if you go by in the participants list, you should be able to. There's a raise hand.
I found the FTC robot controller, but what do I drop down?
Do you find the FTC robot controller folder?
Yeah, but what do I drop down on?
Press you see the arrow to the left of it?
Yeah, but I'm asking which file under FTC robot controller I drop down.
Do you see a folder called Java?
Oh, that one?
Yeah, open that folder, then open org.firstinspires.ftc.robotcontroller,
Mm-hmm.
then external.samples, and then hardware pushbot.
Okay.
Yeah, we've got a couple more people. Yeah.
So I know some of you don't have the Android Studio installed, but the others who have, are you guys having issues finding this folder, or are you good? Just not
I
able
can't
to
find
figure?
hardware pushbot. I can only find hardware pushbot.java.
That's fine, yeah. Just hardware pushbot.java. That's the one that we want. Wait. Yeah, hardware pushbot.java.
I'll open up my Android Studio and navigate after this presentation is done.
There's about like 14 more slides, right? Or something like that. I don't know, a little bit less. Yeah, everyone who doesn't have or is saying that they don't have Android Studio installed, read the message Roshan sent in chat.
Is there a way to pin messages if you're the host?
Can't see.
Mr. Bell.
At least it doesn't give me the ability to do it. So.
No, I'm also not seeing that.
Okay, Sanjay, I think we should just get started with the presentation. So everyone that doesn't have Android Studio fully functioning right now, just follow along the presentation and we'll try to help you after.
Okay, so here's the hardware pushbot code. And you remember in here, we have robot.init hardware map on this side. So what is this doing? That's what we're going to see right now. So this class hardware pushbot, this defines the hardware names and it maps the names used within the programs. And what this means is basically, you see this left motor, right motor, arm motor, left claw, right claw. Just naming it this doesn't mean anything because because when you actually run this on your robot, the robot doesn't know like what the name of this variable, or I mean, it doesn't know what where this motor is. It doesn't know what power to set to it. I mean, it knows, like, it doesn't know what port this is plugged into. So if you guys have done FLL in the past, you all remember how you had a motor port A, B, C, and D. You can think of this as just being like names, but we need to actually tell it A, B, C, and D. So does if that makes more sense, that's basically what we're doing in this init function. We're telling it left motor is at A, right motor is at B, arm motor is at C, left claw is at D. This might be somewhere else. Although the motor ports aren't named that way, it's essentially the same concept. So that's kind of what this initialization does. So now we're going to scroll down to find this public void init. You notice how you have to pass in what's called a hardware map. So this hardware map is a class made by the FTC people, which basically tells you that it returns the motors based on their names. So when it's not exactly the same as it is in FLL, where in FLL it's just you have port A, B, C, and D. In FTC, what you do is you have ports 1, 2, 3, and 4, or 0, 1, 2, and 3, but instead of just using those numbers, what you do is you actually assign the ports a name. And we'll go over this more a little bit later, not this week, but configuration is something else. And configuration is what this means is you tell the phone that left drive is at port 0, right drive is at port 1, left arm is at port 2. And what this hardware map is doing is this is saying, give me a DC motor of the name left arm. Because if you look up here, when we first declared our DC motors, we set them all to null, which means they have no value. They're just basically empty DC motors. Not even they're just nothing. Then once we actually assign them, this hardware map DC motor.get is returning a DC motor. So this gives us a DC motor, and now we know so it returns a DC motor, and that is assigning this left motor to something. So now when we do this left motor.set direction, left motor.set direction, it knows exactly which motor to set it to. It knows to do the left drive motor. So does that make sense, what these first 3 lines are doing? Yeah, basically if you read this, it says that it's mapped to the right drive hardware name. So these have to match the name on the configuration file in the robot controller. And we're not going over configuration today, I believe. So we can explain that. If you want a little bit more explanation on configuration, you can ask us afterwards, or you can ask us now too. This is a good time to ask. And the rest of the stuff is just actually setting up. So like how I said in the initialization, if you want to reset something or you want to make sure something is working, right, set the direction. This is what the initialization function is for. So we're setting the direction of the left motor and the right motor. We're making sure all the motors' powers are set to 0 so that nothing, like, they don't start moving randomly. We start, this run mode is just how it's going to run, and we can explain this. This is basically how it runs. So if you do run with encoder, what happens is it'll run more accurately because it uses the encoder readings to go to a certain position. But this isn't of too much importance. So this run without encoder is, you can just ignore these first 3 lines for now. When we get into like controlling the robot, we'll talk more about it. And then it's assigning the servo. So the servos are assigned the same way as DC motors, but you notice instead of saying DC motor, we do servo. And then we set the position of the servos. So this is mostly, function basically has 2 parts. The init function has 2 parts. First of all, it's making sure that we have assigned our motors to something and our servos to something. Then secondly, it's making sure that we're setting up the motors properly, like setting the direction, the power, and the mode, setting the position of the servos. Does that make sense to everyone? Does anybody have any questions about this? Does anybody else have something to add, like Roshan or someone? Okay, so
No.
Okay, so then now we've talked about an iterative op mode. Like this is an iterative op mode, and we would Roshan, you can show them the code in Android Studio how the actual function works too, right? The loop function.
Yeah, I'll be
Okay,
going
so
over one of the.
yeah, sorry.
Yeah, I'll be going over like an example of one of the drive programs for teleop.
Okay, so that so then you guys will see the loop function afterwards. So that's basically it for iterative op modes, the regular op modes. Now we'll move on to linear op mode. So this is similar to the regular op mode, but it's a little bit different. So rather than having looping constantly, what it does is it runs steps in a linear fashion. And this is the way this works is you can think of this as the reason it's called linear is because it all runs one by one. It's in a line. So it first runs this first step. As soon as this is done, it runs the second step. As soon as this is done, it runs the third step. As soon as this is done, it runs the fourth step. As soon as this is done, it runs the fifth step. If there's no more steps, then the program's over. Basically like that. So now what this does is this is these are the same functions similar to how you similar to the iterative op mode of how there's the init function, there's the start function, there's the loop function, there's the stop function. This has a couple functions too. So first would be robot.init map. This is specific to this hardware pushbot. So the way you do it in your actual robot might be a little bit different than having robot.init map like this, robot.init hardware map. But in this case, that's what they did. Then next is wait for start. So this is probably the most important function of the linear op mode. This says when you call the when you press the init button, it'll run everything before wait for start. As soon as you press start, it runs everything afterwards. So it does this, then it waits for you to press the start button, then it does everything else. Now next is while op mode is active, and this means that it's gonna keep looping while the op mode is active. So if you wanted to do a loop in the linear op mode, in autonomous, you don't always want to do this. Then you would do the robot stuff, and then you would wait for tick. So this isn't as necessary anymore, but it makes it so that it allows the computer to run other processes. So that's why this isn't really used as a teleop most of the time. You would normally just have while op mode is active and then do robot stuff. But yeah, so this is how the linear op mode structure would work if you wanted to use it for a loop. Now for an actual autonomous, right, or that's the reason they have this loop is because they're doing it in a teleop. Now we'll go over an autonomous afterwards because autonomous is a little bit more complicated than this, but you'll see with the linear op mode or with the linear op mode for a teleop, right, or just in a linear op mode in general, instead of having these 4 functions that this iterative op mode had, right? You see there's 4 functions: init, start, loop, stop, even though only 2.
Sanjit, 1 second. Can you explain, does everybody know what's the difference between the autonomous mode and the teleop mode? Can somebody, does any, you guys understand? Some of you have done FTC before, so you guys might be knowing, but about the people, all the kids who are new, do you guys know the difference between both autonomous and teleop?
Autonomous is where the robot drives by itself, and teleop is where the driver drives the robot.
Okay, so everyone knows that, right?
Yes.
Okay, good. All right, go ahead, Sanjay. Sorry.
Okay, thank you. So yeah, that's important. You guys all need to know the difference between autonomous and teleop. So if you've done FLL before, autonomous is basically like all your programs in FLL, where you press the run button on your robot and then it starts to run, it finishes, it comes back. That's it. Autonomous runs by itself. It's all pre-programmed and everything. Teleop, on the other hand, means that you get controllers, like the controllers, you put them in your hand, and then you can start to move your robot by yourself. So it's not all pre-programmed instructions. You're kind of doing the instructions by yourself at the time.
A good analogy would be sort of like a plane. Whenever the pilot is actually flying the plane, that would be basically like the teleop mode. And whenever autopilot is on, that would be autonomous mode.
Yeah. And it's actually, the plane analogy is pretty good because in autonomous, you can use sensors to adjust your path and things like that. But we'll go over that when we talk about sensors. So if you wanted to use a linear op mode for a teleop, you would use this loop structure where you have the wait for start function and then you start looping until the op mode is stopped. So let's talk about how you can make a teleop with the linear op mode. So you'll notice that in the linear op mode, there's only actually one function that you have to override. And this is the function called run op mode. And what this does is when you call this run op mode function, this is literally the whole op mode is inside this run op mode function. That's why this wait for start is really important, because unlike in the regular op mode where you had the difference between an init and a start function and it just automatically waited for you, here you have to tell the robot to wait for you. So if you don't add this wait for start line, this one line that says wait for start, what's going to happen is as soon as you press init, the robot will start. It won't like wait for you to stop. And then you basically have to have wait for start in order for your program to be allowed in the competition, unless if you have some other means of starting it. But I would just go ahead and say that 100% you need to have this if you want to be allowed to compete in the competition, like if you want your program to be run. So this function, right, ff pushbot teleop pov linear, if you want to find this in the same folder, you can. You guys can all find this while I'm explaining because it's the same thing. You'll notice that this extends linear op mode. So that means that it has all the functions from linear op mode. And then this function, it extends linear op mode. And because of that, we can override the run op mode function. And now the first thing we'll do is we'll call robot.init, which is right here, passing in the hardware map. Then after that, we wait for start. Then we start looping while op mode is active. So hopefully all of you have had experience in Java before or programming, but while is kind of like a loop. And what it'll do is whatever's inside the brackets after the loop, it'll keep repeating while this condition inside of here is true. And this op mode is active is basically saying while you haven't pressed stop. So it'll keep repeating while you haven't pressed stop. And you'll notice what's happening inside here, right? Is it's setting the left, this variable called left is setting it to the negative gamepad1 dot left stick y plus gamepad1 plus dot right stick x. So this may seem a little bit complicated, but when you kind of break it down, you'll see what it means. So this gamepad1 is the gamepad. So this is the driver's it's like the controller that they're holding. Then this left stick Y is just getting how much the left stick up and down is being moved. Then it's adding that to the right stick X. And you'll notice this is negative because the Y axis is actually inverted on these joysticks. So it's calculating some powers. And you'll see that it's called a POV op mode. And you'll see that what it means is when you push the stick forward, it'll go forward. If you and basically it explains what it does right here. So the left stick moves it front and back, and the right stick turns it left and right. So you can use this to combine operations and turn and drive at the same time. So this is kind of a cool type of op mode. And you'll see some of the math that goes inside of here is it's basically because it's adding two values, and since the power can't be over 1, it makes sure that it's less than 1, and it scales down equally. And I think Roshan can explain more about this when we get into the actual code of it. Or actually no, he's doing the regular op mode. So I'll explain this. Basically what we're saying, we're finding the maximum of this left and right power. And the reason is because we can't have a power that's greater than 1 because that's more than 100%. And then if either of them are greater than 1, it doesn't have to be left, or it could be left or right. Then what we do is we divide both left and right by the max. And the reason we're dividing them by the same amount is because if we just cap them off at the max, then the ratio between left and right is now different, and now you're going to be turning different than you would be driving. So this is very important. So if you don't understand this, this is a little bit complicated. It's not super important, or it's not super important to understand for the op mode structure though. Then the rest is just setting the power, and this is all like, these are all like checking if certain things are true. Now you'll notice that everything is being called only once, but the reason is because this isn't a loop, this is constantly updating. So this left stick Y value in one loop iteration might not be the same as the other, and that's where you get the experience of driving. So this is constantly running, it's constantly setting left and right, it's constantly setting the power, so it's constantly running, it's setting the motor powers. And that's basically what this sample code does. So the next part is the arm power, right? This is rotating the arm. So if you see gamepad 1.y, this is the Y button on it, then it'll set the power to move up. If the gamepad 1.a button is pressed, it'll set the button to down. It'll make it move down. But if neither of them are pressed, it'll set it to 0. So this is very important for you to understand. In FTC programming, when you set the power of a motor, if I were to set it to 1 and then just leave it like that, it'll just keep going at 1 forever. It'll never stop until you stop the program. So it'll keep going at 1 for that power. If that's what you want, sure. But if you want to press Y and then it keeps moving up and then like crazy things start to happen, right? That's because you never set the power back to 0. Then finally we add some telemetry. This is just so that we can read on the console. And then lastly, this robot.wait for tick 40. This is again not as much importance anymore, but it still can be helpful to have. So you wait for tick 40. So if this does anybody have any questions about what we went over? Again, the linear op modes have only one function. So you see this run op mode function, it starts and ends right here, or like it ends right here, so it ends at the end of the program. So this run op mode function only has one program. And good job, you've completed this part of the learning the linear op modes and the regular op modes. Now now Roshan is going to show you the regular op mode, because this presentation didn't show the full part of the iterative op mode. Roshan's going to show you that part, other than just the init function. So actually, first, does anybody have anything to add or any questions? Anything that like you would really want to know about this, like? No? Okay, so Roshan, I think you can take it from here, and then you can show them the other functions. The op mode, regular op mode.
Just give me like 1 minute to open up my Android Studio. Meanwhile, if you have like any questions, type them in the chat or ask them.
Hello, I have a question.
Yeah, sure.
Yeah, go ahead.
So like for like a code to like start, do you have to have like an init, or like do you not have? So like, is init mandatory for the code to run?
It's not mandatory for the code to run, but you can think of it as
I mean, you don't need to
mandatory.
have anything in the method. You don't need to have anything inside the method. I would just keep the method there in case you do want to update it.
So basically, it's just easier to have the init in it.
Oh wait, no. Init and loop are required. You don't have to have anything in it, but you have to have it in the program because it needs to be there or else it'll be empty. But you can leave it empty though, but it just needs to be in there.
Okay,
The
got
other
it.
functions like start and stop are not required, but you can use them if you want to. But
Got
init
it.
and
Thank you.
loop are required.
Yeah, thank you.
No problem.
Can everyone see my screen?
Yes.
Yeah.
So whenever you guys like opened Android Studio, did it look similar to what I have?
Yeah.
Yes.
Did anyone's not look similar? Okay, so we're gonna just like see where the robot samples are. So if you see FTC robot controller and we open up that, and then there's a file inside that says Java, and then you'll see this big expanded thing, which then have like two main folders. We're gonna be looking at the external samples. So one of the ones we'll be looking at is the hardware pushbot file, and another one would be the teleop. So Sanjay, did we go over the iterative one in the presentation?
We went over the linear one in the presentation. Iterative is the one that you show here.
Okay, yeah, I'll go over the iterative one for tank drive. So if you have any questions, just feel free to like either just interrupt me and say something, and I'll answer it. So what we should do initially to make this file our own file is we would need to copy it to the team code folder. So it's whenever we edit a file, we want to make sure that it's in the team code folder and not the samples, because we don't want to mess with the samples in case something does go wrong, and we want to refer back to it. So I just went ahead and copied it, and I'm going to go down to the team code folder, and then you'll see it says org first inspires FTC team code. I would just go ahead and paste it. So then it's going to ask, like, do you want to change the name? Which you can if you'd like to, but for this sake, I'm just going to leave it. And another thing is that right now it's referencing this hardware pushbot file, which is in the samples folder as well. So I'm going to copy that as well and bring that into the team code so that we can customize our own hardware file depending on our robot. So then what I want to do right now is I want to change this hardware pushbot to correspond with the hardware my robot, which I've created right here. So the first thing is that we would need to change this class name because that's where it's called. So I'm just going to go ahead and change that. And then since we changed the declaration, we would also need to change the initialization. So I'm just going to copy that over. And then now if you look at the imports, this one is grayed out since it's no longer being used. And we could look if there's any other references of it, which there isn't. So we can just go ahead and delete this line or comment it out if you'd want to.
Do you want to wait for everyone to catch up?
Yeah. I can't
So
see the questions, so I can't see the chat.
Okay, I can tell you if anyone asks a question. But raise your hand once you guys are caught up to this point. If you're somewhere like far behind, please ask, like unmute and ask or send it something in chat.
So right now I just copied the 2 sample codes. So the first one is pushbot teleup tank iterative, and the hardware pushbot, which I renamed as hardware my robot, which you could rename to whatever you want.
Would now be an okay time for us to open the breakout rooms, or is it not good right now? Because Gia needs help with the uninstalling, and I'm sure other people need help with just things in general.
If you have any issues, could you send a message in the chat so we can kind of get a sense of like how many people actually need help and see if we need to open the breakout rooms now?
Yeah, that's a good idea.
Rama, I think, could you ask your question? Just like use your mic so then we would know what your question is.
On mine, it doesn't have the like other code that says hardware my robot.
Yeah, so do you see where the folder is that says external samples? Do you see where my mouse is?
Uh-huh.
So if you scroll down, do you see what I'm highlighting? Hardware pushbot.
Yeah.
So go ahead and copy this.
Okay.
Okay, so then scroll down. Do you see where it says team code?
Yep.
And open all the folders, Java, and then until you get to this folder that I've highlighted.
Mhm.
And then click paste.
Mhm.
And then you should see a pop-up that asks you if you want to rename it. I chose to rename it because your robot's obviously not going to be a pushbot.
Okay.
So that's where I got hardware my robot.
Okay, thank you.
Wait, hello, excuse me?
Yeah.
When I did the team code thing, all that pops up for me is src build.gradle and build.release.gradle. I don't see like a manifest or Java thing in my thing. So what should I do?
Did you see where I've like highlighted up here?
Yeah, the Android. I'm on the Android thing.
You're on the Android?
Yeah.
Are you also on project?
Yes, I am on one project.
So what?
I think
you said you don't see this?
Like, wait. So do I
like
have to
if you
click
see it like this?
Do I have to click like the arrow under team code?
Is this how you see it?
Wait. Yeah, kind of.
Yeah. So you have to open up your folders.
Oh,
Click
no,
the
no,
arrow next to team code. Yeah.
Yeah, I see it now. The Java. So I have to open the Java thing.
Yeah.
So like, how do you open it? Do you just double click it, or there's like an
It's a
arrow
folder.
there?
Yeah. You can either click the arrow or you could double click.
Yeah, click the arrow.
This is me double clicking, and this is just the arrow.
So which one should I do? The arrow?
It doesn't matter.
Whatever you like.
Got it.
Roshan,
Yeah.
after copying the code, what's the next step?
So did you copy the hardware pushbot file as well as this file into the team code folder?
Yeah.
So then I went into the pushbot. So yours should look like this. You see this line?
Yeah.
Okay, so you want to change this hardware pushbot to whatever you called it here. So right here, I called it hardware my robot. So I'm just going to rename both this and this to hardware my robot.
Okay.
See, I'm going to take this and then I'm going to copy it over here.
Excuse me?
Yeah. Go ahead.
So like, when I click the down arrow to the Java thing, where, like, for me, like, where are you supposed to like print the pushbot, shell top, tank?
It should. If you go to FTC Robot Controller, click on External Samples, and then try to find where this file is. So it's right here. Just copy this file, and everything should be there.
Pushbot, shell tank. Okay. Intern. Okay.
It's in the external samples, so you want to copy it from the external samples onto your team code.
Okay.
So right now we
If you
should have
didn't
two
change
files in our
it,
team code.
if you didn't
Could
change
you
it to
repeat?
a MyRobot and you left it as pushbot, would that still be okay?
You would want to remove your import statement. So if you go to hardware my robot and scroll up, you would see an import statement, which I deleted, but it exists. So there's going to be like an import statement here that refers to the pushbot. You would want to delete that line. It's the last
Isn't
line.
it in the isn't it in the other file, the pushbot teleop tank? That's what the import is.
Sorry.
The
Okay.
import is in the
yeah,
this one.
Yeah, sorry, it's in this one. My bad. So you would want to delete this line that you see, so both the classes don't interfere with each other.
Okay.
Because even if you rename it, if you read this import statement, or even if you keep the name the same, if you read the import statement, it's saying org.firstinspires.ftc.robotcontroller, but we need to have org.firstinspires.ftc.teamcode. So it'll be importing the wrong one. And then since they're in the same package, they're both in team code, you don't need to import it at all. It's just there. So you just delete the import statement if you're keeping the name the same, or if you're changing it actually.
Could you raise your hand if you've got to that point?
There are a lot of people who are late and who need help. So it might be good to actually open the breakout rooms now. Or shortly.
Who's speaking?
This is Vasu.
Oh, okay. I think Amrit's the only one that was late. Suggesting that he could just watch the video of the parts that he missed, the screen recording.
Oh yeah, sorry.
Because we just covered a PowerPoint presentation. There's really no breakout room that could get you caught up with that.
Okay.
Okay, so Arash is asking, how do you rename? You can right click, or can you show them, Roshan?
Wait, so when you copy it directly, you should get a pop-up that tells you to rename it. So if you've already got past that step and clicked OK, you can click refactor and then go up here and where it says rename. And then you could rename it to whatever you want. So for the sake of purposes, I'll just do this twice. I'll just call it my robo and then click refactor. And then it should take care of everything by itself. It updated that, it updated that.
And then someone is saying in the chat, I copied it, but I don't understand what to do next. So once you've copied it, go to
I'm just waiting for everyone to get here.
No, but did you paste it? Sorry, I wasn't understanding the question. I thought.
Oh,
could you confirm
so if you
in the
copied it to the team code folder, then you're good. And we're just waiting for a couple other people to catch up. But if you just copied it and haven't pasted it, you would need to go into your team code folder, open up Java, and open up this folder and just paste it there.
Wait, I don't have that the org.thingy under my Java. I only have, under my Java, I only have I have the org, the first inspires FTC team code, and readme.md. What should I do?
Wait, what do you have under it?
So basically, under my Java, it says the file named org, a file named first in series, a file named FTC, and a file named team code. And then there's a
yeah,
folder
open all of those up.
Okay, open all of them.
I mean, just select the team code folder.
Team code.
And then inside the team code folder, is there a README file?
Hey, Roshan and Grace, do you want to start the breakout now?
Yeah, there's a name.
I mean, I was going to go over the code, and I really don't want them to miss that part.
Okay then, no problem. Just
Roshan, I was just thinking that there are a few kids who are still, they don't have the install and all those things, so they might totally left out. So there are at least 4 or 5 of them. as I understand. So are we doing okay with the time? It's 7:10. How are we doing with the time? You think we can take a quick 10 minutes?
Let's see what they have to say. So could you guys, the people that haven't installed Android Studio yet, could you comment whether you prefer to wait till the end after the presentation to get that installed, or do you want to do that right now and then catch up on this with like the screen recording? Just type like your quick answer in the chat, and then we'll do whichever one you guys want to do.
Excuse me?
Yeah, go ahead.
So basically, I opened a team code thing, so do I need to, like, rename it, or?
You don't rename the team code folder, you just paste inside that folder.
So what should I paste?
So the first one you should copy from the external samples. You have external samples opened up, I assume. So we're going to go to hardware pushbot, copy this, and then go down to your team code folder and then click paste.
Yeah. And then click paste.
So and then it should give you a pop-up that allows you to rename.
I said okay, and then so then there's a hardware pushbot.java. So what should I do with that?
So let's just do a quick 5-minute. Maybe the installs we leave it. Like anybody has quick questions on these code kind of issues, maybe have a quick breakout room, just 2 minutes, and we can.
Yeah. So I'm just gonna go over the copying like one last time if anyone didn't understand. So just pay attention and then try to do it by yourself. So there's a folder inside the external samples called the hardware pushbot. We want to copy that folder, and then we'll scroll down to the team code folder, and then open up Java, open up the other folder. It should contain a README folder inside of that. We want to paste the hardware pushbot file. So then you'll get a pop-up that allows you to rename it. I renamed it to hardware my robot, and you can rename it to whatever you want. Just remember what it is. And then I went up to the pushbot Teleyop tank, copied that, and then pasted that as well. So that's as far as we got. So I'm going to move on. So the first thing I did is I changed the hardware pushbot right here to hardware my robot, so it corresponds to my hardware file and not the pushbot sample hardware file. So in this file, the hardware file will have like all of our constants and different we're basically going to initialize all the robot hardware in the hardware. This is like where we say that we have a certain DC motor or servo, so that we can refer to this in like multiple different classes. So right here, we're going to initialize it, and we're going to say hardware map.get and then the class. And this is the device name, which you'll set in the configuration file, which is going to be on your phone. So we do that for all of our motors, and as you can see here. So the first thing, you'll see this init method run when we go to our pushbot Teleyop tank file. So in the init method, which is the first thing that runs, it says robot.init hardware map. So what robot.init is, so if we follow where this robot is, I highlighted this, so it says it corresponds to this one. So inside this file, you'll see an init. So I can just click on the init, and it's going to go directly to it. So what it does is it's going to call this method. So this is the first thing that's being run, and that's being the configuration of all the motors and servos and everything that you have on your robot. Does everyone understand that part?
Yeah.
Okay, so we're this is right here is we're just saying that the device like name, which is our configuration file, we're just saying that in the code so that when we're running through it, it can like correspond to each other. And then left drive and right drive is, it's basically saying the direction that you want forward to be. So you get to set which way you want forward to be. And then right here, it's we're accessing the DC motors right here, because if we see left drive, you can see the type as it's declared in the first line. So all the left drives and the right drives are all DC motors, which is the motors you'll mainly be using to drive your robot. So just to start, we want to make sure it's not moving or anything like that. So we're just using the set power method to set the power to 0. And then here we're setting the mode. There's different run modes. So there's run without encoder, run using encoder, run to position. So depending on what you want to do, you would use the corresponding mode. So in this case, let's say you don't have any encoders installed, so then you just want to drive the robot manually, you would use this mode. And then right here where Servo, which is a different type of hardware, is being initialized, it's basically the same. As you could see the similarities in the DC motor and the servo. The only difference is that we're declaring it as a DC motor and a servo, so it corresponds to the appropriate device. And then similar to setting power in a DC motor, we're setting a position in a servo because that's the way that the servo works. So let's say you wanted to go to the center whenever you start the match or whenever you click Init. So mid servo is a constant, as you can see, because it's all uppercase. So if we go up to see what that is, it says public static final double mid servo. So from the Java class, we should know what a double is and like the value it stores. Mid servo is just saying that 0.5 is in between 0 and 1, so that's the position it's going to go to. We just say final so that we know that we can't change this value in the code. Like I can't go here and say mid servo equals like 0. So this value is a constant and we can't change that. So that's basically the initialize method, which is like the first thing that's being run. So telemetry is just saying like, oh, it's like giving feedback so that you can also see what's going on. So after it inits, it's going to say hello driver, and it's going to output that on the phone. So this is run once as seen by the comment. And then after we run the init, it'll give you an option to click play. So when you click play, once you click init, this will run once. So it's going to set the servos and set all that stuff. But if you want to loop something in initialize, does anyone have like an example of something that we would put inside here? So usually for drive, there's not many.
Roshan,
Yeah.
I think you might have to just explain to them what is telemetry and all those things, at least for the new kids who are doing, yeah.
So does anyone know what like system.out.println or like just a print statement in any language is? So what it is it like displays like messages to the console so you can like debug, right? So telemetry is pretty useful for debugging things. Let's say you want to know what the certain value of a motor is or a variable. So we can just print that out using telemetry.addData. So then we can like see a display when it's running of what the value is. So once we click the start button, if you have anything else you would like to initialize, you could go ahead and do that right now, or if you want to run like a certain part of the code just once, you could do that. And then as soon as it completes whatever is in the start method, it's going to repeatedly run the loop method until they hit the stop button. So we can go through what this loop method is doing. So right here we're creating two variables, left and right. And since this is a tank drive, both the left and right side will basically be independent of each other. So right here on the left, we're getting the gamepad 1. Did someone have a question?
Yeah, I have a question.
What's your question?
So basically, to debug the program, you have to do the telemetry dot add data to show bugs.
I mean, it's not gonna like explicitly show what your bug is, but you could use it to help you find bugs and help you solve whatever those problems are. So let's say there was like an inconsistency in like some variable, or you weren't sure of like what it's doing. So you could print out that value to like verify your hypotheses of whether or not that's actually causing the issue or not. So it's like a good way to see the data and to verify if what you thought was happening is actually happening or it's not.
Okay, got it.
Okay, so we created the two variables for left and right. So far, they're not set equal to anything. So right here, in the loop, we're setting it equal to the gamepad 1, which is one of your gamepads, and left stick Y and right stick Y. So both of them, each gamepad will have like 2 joysticks, and the Y-axis is the up and down axis, but we add a negative sign so that it's actually the way we think it is. So after we put the negative, when we move up, the value will actually be a number greater than 0, which would make sense. And we do the same thing here, so that once we move up from 0, the value is actually like a positive number instead of being a negative number. So then after that, we access the robot class once again, which is, if you go up, it's referred to as hardware myrobot. And when I go in the file, you can see these are all the left drive, right drive, which is being referred to down here. So when we say robot.left drive, it's actually going into this class and calling this variable. So we're gonna, since these variables have already been initialized as motors or sensors or whatever you want them to be, we'll be just using that consistently throughout all of our programs. So we have one hardware file and we don't need to continuously like recreate what's already there. So then we're going to use the set power method as we did in the myrobot class when we set them all to 0. So here we're going to set them to the joystick value. So since the joystick value outputs a value from 0 to 1, that's already like satisfies the requirements of set power, which accepts a value from -1 to 1. So let's say you have a negative like value here, then it would set the power in the negative direction. So if you like push forward both the joysticks and you see that it's going like it's turning, then there might be an issue in your set direction method where you incorrectly configured one of the motors. So if both of them were forward, then think about like both the motors that are facing each other, and if they're going both clockwise, then the issue is that they're pivoting instead of moving in one direction. So here is the controls for the claw, which is a servo, which it's like right here, as we see, it's defined as a servo, and also up here. So these are different buttons on the gamepad. So once you click on the button, it's going to, I'm assuming everyone knows what a Boolean is. If not, it's basically a value that can hold either true or false. So if the button is pressed, then it would say true. And if it isn't, it would say false. So when we read, if statements always check if this whatever is inside the parentheses is true. So if gamepad1.right bumper is true, then it's going to run this claw offset equals claw offset plus the claw speed. So here, the claw speed is another constant that we could see in this class. So it's going to increase by 0.02 every single time, and it starts at 0. So we're adding to it if we press the right bumper, so it's going to increment the servo position, which we'll set down here. And then right here is the claw offset. offset when we subtract it. So we're reducing 0.02 every single time the left bumper is held, and this left bumper returns as true. So right here, what we're doing is we're clipping the range. So the max for a servo is negative 0.5 to 0.5 in this case. So they don't want it to extend those boundaries, whether that be like it physically can't do that. So it's like a way to have like a soft limit on software. So here we're doing something similar to set power. We're referencing the robot class to get the servo, and then we're setting the position similar to how we did in the initialize function here. Right here, where we set the position to mid servo. So we're setting it to whatever mid servo is plus the claw offset. So mid servo is already 0.5. So when we if the lowest value is negative 0.5, then we're going to 0. And then here, if we like subtract it, but if the claw offset is like 0.5, the maximum, it's only going to go to 1. So we're not exceeding the range of motion in either direction that way. So that's why the range.clip function is there, to make sure it doesn't exceed the bounds or the physical limits of the servo. So this is another DC motor, which they're using the Y button to hold, to move it in one direction or the other until you stop it. So when you hold Y, this value is going to return as true. So it's going to set the power to whatever arm up power is, which is again a constant defined in the hardware MyRobot class, as seen right here. So if Y is being pressed, then it's going to continuously move the arm up. And once A is pressed, so we're doing else if. So if it enters this, then it's just going to skip out of it and not consider the others. So this way you don't send a request for the arm to move both up and down at the same time. So if neither button is being pressed, it's going to set the power at 0 and not move. So again, we see the telemetry function right here, which is being used in a different way to output what the speeds are. So left and right correspond to whatever the joystick value is, as seen right here. So we're leaving the left as the string, so we can like see that this value is going to correspond to the variable left. So this is just like so that us humans can understand like what this value is actually corresponding to, instead of just seeing like 4 values at the same time. So same thing here, we're seeing claw and then the offset, and then this part right here corresponds to whatever variable is right here. So it's going to run that repeatedly throughout your teleop match until we click stop. So as it says right here, code to run repeatedly after the driver hits play button, but before they hit stop. So it's going to continuously loop until that stop button is being pressed. So if you have anything to do after the game has ended, like resetting anything or anything like that, you could call that in your stop method. So does anyone have any questions about this class?
So Roshan, do you want to just like ask them like some of the question, like instead of asking if they have questions, just ask them a few questions based on your code, like if they got that. So how many of you understand the difference between DC motors and the servo and all those kind of stuff?
I don't really understand the difference.
So Roshan, you might have to just give them a little bit background on why you had the DC motors and all those things kind of thing. And how many of you got like what was happening in the code?
I got it.
Is this your second year of FTC? First year of FTC though?
First.
question. Okay, let's see if anybody else so you guys shouldn't be feeling shy. If you have a question, you can always ask, interrupt and ask. Feel free to ask if you don't
understand.
Okay, let's see if somebody didn't get it. Please go ahead and ask if you guys have any questions.
So what really is the difference between DC motors and servos?
Roshan, do you want
Sajid or Joshua, do you want to answer that question?
So DC motors and servos are both types of motors. I'm just gonna pull up two pictures of a servo. You guys have probably seen them before. I'll tell you that you've most likely seen a servo before and you've seen a DC motor before. I'll just pull up two pictures. 1 second. Can you stop sharing, Roshan? Okay. Just give me a second. 1 second.
And give an example when, where does the DC motor go? Where does the servo go? Kind of just a very basic example too.
Yeah. Just give me 1 second. I've got a good picture here. So, here. So right now I'm going to show you a servo. So a servo is, does this type of picture look familiar to any of you?
Not really.
Yeah.
Okay, so yes. Okay, so some of you it's familiar, some of you it's not. That's fine. 1 second. So this servo, so then I'll show you another picture. This one you may not be as familiar with, but this is the Rev HD hex motor. So this is what you would call a DC motor. This one is called a servo. So normally servos, if I go into the actual details on it, right? You can see, right? Let's see if they have something like the size, right? So this is 54 millimeters by 40 millimeters by 20 millimeters. So it's not too big. It's it could fit in the palm of your hand a little. It's not too small. Then this one is, now it's not the best idea to just compare them solely by size, but you can see the diameter of this is 37. It's not telling me the length, but basically what I'm trying to say is, first of all, if you see two things like this, the one that's bigger is probably more likely to be the motor, but you should not use that as your only way. So in here, you'll notice that the way it's plugged in is this type of cable right here. It's you can see it's a red and black cable. So many of the DC motors that you're going to use in FTC will have this red and black cable. For servos, there's usually a, sorry, what? For servos, there's usually a cable already attached, but that's not the only way that you can tell the difference. So now the applications are the big difference. So basically in general, hex motors, DC motors are stronger than the servos. So if you were to make a drivetrain, or you wanted to drive your robot, you would use DC motors to drive your robot. And you remember in the program, left motor and right motor were both arms. Now, if you wanted to, for example, move an arm, right, that would also use a motor, because that's a pretty heavy load application. In contrast, right, some small applications would be for example, the claw, you wouldn't really need a big servo. You wouldn't need a big motor for that. You would use two small servos. And also, one of the other reasons you'd use servos is because we have a limit in FTC. You're only allowed to use 8 motors, but you might have to have more than 8 moving parts, but you're allowed to use 12 servos. So these servo motors are a lot. These servo motors are a lot smaller. These servo motors, you can see my screen still, right?
Yeah.
So these servo motors are a lot smaller, so they can fit into more compact spaces, but they're not as strong. But you can use more of them, and these the DC motors are a lot stronger. They're faster. They're more powerful in general, and you would use them in more high load applications. Another main difference between the motors and the servos is, For the motors, they go full 360 degrees, and this motor will go 360 degrees and it'll keep spinning. It can spin forever. Like it can keep going and it'll keep spinning, and it can keep spinning. It can spin backwards forever. There's no limit on the motors. For the servos, there's two types of servos. There's a continuous rotation servo and there's a standard servo. The standard servos have the limit usually around 180, but sometimes they can go up to like 270. There are some servos that'll say they can do multiple rotations, but usually it's saying it has a limit at 360, and it's like it can't turn more than that. You have to turn all the way back around. So these servos are a lot harder, they're not really good for like full rotation things like a wheel would be. Meanwhile, another thing about servos is that you can set the exact position. So for the motors, you have to use an encoder. Like you have to use an encoder to be able to tell the position of it. But for a servo, this wire tells you the position and it lets you set the power. And that allows you to basically set it to a position rather than just set a power.
Okay, so basically you should use servos for like small things and like DC motors for bigger stuff?
Basically, yeah. Joshua or Roshan or Fasu, or does anyone have something to add to that?
Yeah. So if we're gonna compare it to FLL, the DC motors would be like a large motor, and those are used to control the wheels. Servos, a continuous 360, a continuous servo would be basically a medium motor, where it can handle a bit, but it can't handle as much power. And I know that wasn't there during FLL, but imagine that there was a small motor. That would be basically the regular servo that could only go like 180 or 360 degrees.
Oh, okay.
Yeah.
Okay, thank you.
Mm-hmm.
Do we have any other questions? Anything either you didn't understand in the code that we need to go through, or questions like hardware that we just had? If no one has any questions, we could split up into breakout rooms and address like specific things that people had issues with, either with Android Studio or something like that.
Yeah, and one of the things which I would recommend is all of you guys to try out the code by yourself. And if you come across some issues or something, ask questions the next time. Like we could keep about 10 minutes in the beginning of next session where you guys can clarify your doubts about anything. Or you guys can feel free to send email to Roshan, and he would he'll answer those questions. So just don't leave it after you leave today. Don't look at the code again and try to figure out more. That's what I'm basically saying.
I have another question.
Yeah, go ahead.
So basically all this code that like you're gonna write for the robot, will this code all go to like a controller to like control the robot, or?
Yeah, so you have like one phone, and either you have a second phone this year or you do have an alternative to use the Rev Hub. So whichever one you choose, the configuration is kind of similar. So you would deploy your code onto it, and then you would have one driver controller phone, which you would plug in your joysticks to.
Okay.
So
like,
that's the part.
Will the controller be like an Xbox or like a PS4 controller, or is like a controller that you make up?
A PS4 controller.
No, it's
yeah.
It's not a. It's got a same
sort of
layout
like
as the PS4 player controller, but also you can use an Xbox 360 controller.
Yeah.
But most teams use. If you want to know the exact name, I'll send it in the chat. It's called Logitech F310.
Wait, can you type it in the chat, please?
Yeah, the layout is the same as the PS4 controller, but the it's just a lot cheaper than the PS4 and Xbox controller.
Got it. Got it. All right. Thank you.
So should we split up? Should we split up into breakout rooms to address any concerns that anyone has? So, could you say something in the chat if you need a breakout room or assistance with anything?
Or also raise your hand if you need help or something like that. Just
Also,
anyways indicate.
if any teams does like already have like a chassis or something, I would try to develop a Teleop program for it if you don't have one already. So you could use the sample code that we have. You might need to make some modifications or like comment out stuff you don't have, but I would attempt it, right? So see how far you can get, and even if you can't get that far, that's okay. Just if you have any questions, you could either email me or write them down or something to address in the next meeting.
All right. So how many of you have issues and need individual help? Like Adit, okay, 11244. Adit has got an issue. Who has 11244?
It's Joshua and me.
Okay.
I can do.
No, 1124 is Krishna, right? That's the mentor assigned, and Amanda.
Oh wait, never mind. Sorry, I had
Yeah,
11254. My
54,
apologies.
yeah.
So there are two of them from the same team. Maybe we move one to the other room. Joshua, can you have one? Joshua, are you there?
Yeah, for sure.
Okay.
Okay, I'll move
Joshua.
Adit to Joshua's room.
Okay. So
just doing a time check. So it's a 7:43. So how long we are going to keep the breakout room open?
I think you
It
guys think
shouldn't
15.
take more than 30 minutes.
Okay.
Let's do 45 minutes just for the sake of it, and then we'll see.
Okay. Okay. So I'm going to open a room. So whoever wants to go, you can accept and go. Others can continue on this call. Okay. I am just opening the room. Just making sure everybody is, everybody's assigned to your.
So Aditya has some questions somebody wants to answer. And the class, if you guys don't have any issues, Roshan, do you have anything else to cover for today, or are we done? Like, can the others log off, the ones who don't have any issues?
Yeah, I think if you don't have any issues, I would just try to attempt to make your own Teleop program, but that's about it. So thank you all for attending. And if you don't have any questions, you're more than welcome to leave.
And if you guys have any feedback, please feel free to let us know. This is the first time we are doing the class virtually. So we know that there are some, like it's not the same as being in person, but we are open to any suggestions which you guys have to make the class better. I know some of the parents are online too. So please feel free to let us know. Email us and let us know what we can do to make this class more interactive and more interesting for the kids.